Welcome to Building Integrated Photovoltaics. Discover our colored PV building materials and many other solutions by Onyx Solar. In this audiobook, we will explore how our innovative photovoltaic glass not only enhances the aesthetic appeal of your buildings, but also significantly reduces energy consumption and carbon emissions. You will learn about the unique properties of our PV glass, the economic benefits it offers, and how it can be seamlessly integrated into various building designs. Additionally, we will take you through some of the remarkable projects we have been part of, showcasing how our solutions have been successfully implemented across the globe. Chapter 1. Introduction to Onyx Solar PV Glass. Money, energy, and carbon savings without sacrificing comfort and aesthetics. Our glass can be customized to block the heat that enters the building and to provide the best insulation, thus avoiding the use of air conditioning and heating. It also allows the entry of natural light, which prevents the use of artificial light. Just with these passive measures, any building can reduce its energy consumption. The most remarkable aspect is that the same building material that has these extraordinary passive properties can also generate on-site renewable energy that the building needs for its operations. This is what we call active properties. The combination of these extraordinary passive and active properties in one single building material is what makes our PV glass unbeatable for all those who aim to build a net-zero building or simply save energy and money without sacrificing comfort and aesthetics. About the energy payback. The average energy payback time of our glass is under 2 years, meaning that the glass needs approximately 2 years of power production to offset the amount of energy used in its fabrication. This leaves over 28 years of clean energy production, contributing to the achievement of carbon-neutral and carbon-negative buildings. For better understanding, energy payback refers to the time needed for an energy generation system to recover the full amount of energy invested in its production. About the economics behind our PV glass. Photovoltaic glass not only offsets conventional building material costs, but also provides a tangible return on investment through energy generation. With an average payback time of 4 years and yearly ROIs of up to 20%, it stands as a sound economic choice. For better understanding, financial payback refers to the time it takes for an investment to generate enough positive cash flow to recover its initial cost. Chapter 2. How to add value to any building. Photovoltaic glass offers multiple installation possibilities within the building envelope, including curtain walls, both vision and spandrel, facades, sunshades, railings, skylights, canopies, and walkable floors. While maintaining standard structural and thermal properties like conventional glass, it uniquely provides an active function, free, clean power generation, like traditional solar panels. Suitable for both new constructions and renovation projects, our products integrate solar power generation with the high performance and durability associated with architectural glass. Fully customizable in form and function, PV glass provides architects and clients with design freedom. A diverse range of glass configurations and dimensions are available, from laminated safety glass to laminated insulating glass. Additionally, options for solar technology type, transparency level, shapes, textures, colors, and finishes offer extensive customization possibilities. This combination of variables ensures products meet various design criteria concerning U-value, SHGC, VLT, reflectivity, and glare. Internationally recognized, our product has garnered numerous awards, including the prestigious title of Most Innovative Glass Product by the U.S. National Glass Association. Comparison of Onyx Solar PV glass to other products. In this section, we will provide a detailed comparison of Onyx Solar's photovoltaic glass against other commonly used building materials, including high-performance architectural glass, conventional solar panels, and materials used for cladding. This comparison highlights the unique advantages of our PV glass, showcasing its superior capabilities in various critical areas, such as electricity generation, visible light transmittance, solar factor, insulation performance, structural properties, aesthetic integration, and customization options. By understanding these differences, you will see how Onyx Solar's PV glass not only meets, but often exceeds the performance of other products, making it a versatile and efficient choice for modern building projects. Electricity generation. Onyx Solar's product generates up to 180 watts per square meter, comparable to traditional solar panels, while other materials like high-performance architectural glass and cladding materials do not. Visible light transmittance, also known as VLT. Our glass offers VLT from 0 to 75%, similar to high-performance architectural glass, unlike other materials and conventional solar panels. Solar factor, or G-value. Our PV glass provides a customizable solar factor ranging from 6% to 41%, offering superior control over thermal comfort, as well as to high-performance architectural glass. Insulation performance, or U-value. Our glass achieves U-values up to 0.7 watts per meter square Kelvin, matching the highest insulation performance of top-tier architectural glass. Structural properties as construction material. Onyx Solar PV glass and high-performance architectural glass offer superior structural properties, while conventional solar panels do not. Aesthetic integration. Both Onyx Solar PV glass and high-performance architectural glass allow for aesthetic integration, unlike conventional solar panels. Customization in colors, sizes, and shapes. Our PV glass, high-performance architectural glass, and cladding materials offer extensive customization, whereas conventional solar panels do not. Having explored the comparative advantages of Onyx Solar's photovoltaic glass over other building materials, it's clear that our PV glass excels in numerous critical areas such as electricity generation, insulation, and aesthetic integration. These strengths are further highlighted when we delve into how our glass performs in specific applications and under various design considerations. Clean electricity generation. Photovoltaic glass harnesses free, clean energy from sunlight through embedded active layers or cells of photovoltaic material within the glass. The energy output of PV glass varies based on several design factors and installation type. Key design factors include solar cell density, which is the number of solar cells within the glass, and glass dimensions. For instance, a high-density crystalline silicon product with low transparency offers 180 watt per square meter, whereas a low-density one with high light transmission provides around 100 watt per square meter. Balancing nominal power, kilowatt rating with light transmittance is crucial to ensure the product aligns with design intent and performance requirements. Visible light transmittance, or VLT. Visible light transmittance stands as a critical design consideration when choosing architectural glass for buildings. Whether it's for a spandrel condition or a vision panel, Onyx Solar's PV glass can be tailored to offer a diverse range of VLT levels, ranging from 0% or fully opaque to up to 75% VLT. However, it's essential to grasp the inverse relationship at play here. The greater the transparency of PV glass, the lesser energy it will harvest. While spandrel and solid cladding applications may benefit from maximum performance with high solar cell density, vision areas require less density to meet optical requirements and ensure comfort. Solar factor, or G-value. The solar factor, known as the G-value, or SHGC, tells us the amount of energy that glazing will allow into our building in relation to the energy it receives as solar radiation. This is a key factor in achieving indoor thermal comfort in buildings. For instance, a high G factor might cause the temperature to rise too high due to the greenhouse effect, while low values will prevent this, particularly in a hot climate. Onyx Solar's photovoltaic glass typically displays a solar factor between 6% and 41%. Turning it into a great material to provide control over the interior temperature. Insulation performance, or U-value. Expressed by the thermal transmittance of the glass, the U-value represents the amount of heat that passes through the glass when there is a temperature difference between its two sides. The lower the U-value, the better the thermal performance of the glass. This helps buildings become more energy efficient and saves costs. Onyx Solar's glass offers U-values up to 0.7 watts per meter square Kelvin, matching the highest insulation performance offered by top-tier architectural glass products. As a curiosity, did you know that a skylight of 1,000 square meters of photovoltaic glass could power over 17,000 energy-efficient 12 watts light bulbs for 4 hours every day in the city of Los Angeles? That's the remarkable potential of this product. Onyx Solar stands as the top manufacturer of photovoltaic glass for buildings, providing a range of solar technologies, including amorphous silicon cells, monocrystalline, polycrystalline, and bifacial crystalline silicon cells. Tailoring to design preferences, solar cells can either be fully exposed, allowing them to be visible, or partially and nearly entirely concealed, resulting in a panel with a uniform color that resembles conventional building materials. For more technical information, please refer to our technical guide available on our website. Chapter 3: Energy-Generating Building Materials. Building Integrated Photovoltaic or Conventional Solar Panels. Solar panels function separately from primary building elements, typically overlapping with existing materials, resulting in distinct entities and cost centers. Conversely, our photovoltaic glass is viewed as a primary building envelope component, seamlessly integrating into the structure while generating clean power. A truly building-integrated PV application offset the expense of alternative conventional construction materials. Usable area and total system size. Numerous buildings face constraints on available roof space for traditional solar panels. However, PV glass offers a solution by tapping into the energy generation potential of the entire building envelope. In rooftop applications, PV glass can be designed to withstand foot traffic, maximizing the area available for PV installation. Facades, on the other hand, present even greater opportunities, potentially providing a tenfold increase in energy generation. This is achievable because PV glass can be seamlessly integrated across entire curtain walls and cladding areas, among other applications. Aesthetics. In the building integrated photovoltaic market, design flexibility is paramount for success. Architects vary greatly in their preferences, requiring products tailored to their unique needs, functions, and aesthetic sensibilities. Onyx Solar has dedicated substantial efforts to product development over the years, subjecting each PV glass design to rigorous testing through exhaustive R&D programs. The result is a diverse range of unique products that offer extensive aesthetic possibilities for clients of all kinds. From shape and size to thickness, configuration, color, and texture, Onyx Solar provides a plethora of customizable variables to choose from. Class A for fire resistance. Our PV glass is classified as Class A for fire resistance, meaning it is non-flammable and ideal for construction projects, ensuring both safety and efficiency. Unlike any solar panel, which at best are classified as C or D, offering a significant advantage in terms of safety and performance. Cost implications. It is important to understand that our photovoltaic glass is a building material in itself. Conventional PV installations require an additional building structure, such as a roof structure underneath. The combined cost of these building materials, along with conventional PV panels, is much higher than installing a building material with integrated photovoltaic properties. In this context, it is important to emphasize that our building materials serve a dual function. They act both as building material and as solar panels. Moreover, such applications often qualify for substantial tax credits and incentives across various markets, rendering them unbeatable in terms of ROI and payback. Is our PV glass affordable? Ralph Zucker, CEO of Bell Labs in USA, says, "The economics of replacing the existing glass with photovoltaic glass were shockingly affordable. Most likely more affordable than simply cleaning and replacing existing glass with simple glass." Chapter 4. About our product. First, to fully understand how photovoltaic glass technology works, it's essential to grasp the concepts of energy, power, and cell density. When we talk about energy, we are referring to the total amount of electricity generated by the photovoltaic glass over a period of time, measured in kilowatt per hours. This energy is the cumulative result of the power produced by the glass throughout that period. Regarding power, it refers to the ability of photovoltaic glass to generate electrical energy at a specific moment, measured in watts or kilowatts. Power is an instantaneous measure of how much electricity the glass can produce under certain sunlight conditions. Lastly, when we consider cell density, we are referring to the number of photovoltaic cells contained within a glass installation. A high cell density means there are more photovoltaic cells per square meter, while a low cell density indicates fewer photovoltaic cells within the same area. Crystalline silicon technology. Crystalline silicon glass is the best choice for projects where maximum power output per square meter is required. The power capacity of this type of glass is determined by the number of solar cells per unit, usually offering a nominal power between 100 to 180 watts per square meter. This varies according to the solar cell density required for the project. Finding the right balance between natural light transmission and nominal power is key to achieving energy efficiency goals. It is made up of solar cells that measure 158.75 by 158.75 millimeters, approximately 6 and 0.25 by 6.25 inches. Although these cells are inherently opaque, they can be spaced apart to varying degrees, allowing for adjustable light transmittance tailored to specific design needs. The PV glass can thus offer a transparency range from almost 0% VLT to as much as 75%, depending on the project's requirements. Typical balance between cell density and VLT. For example, when the cell density is low, the system reaches 111 watts per square meter, with a visible light transmittance of 43%. Increasing to a medium cell density raises the output to 141 watts per square meter, reducing the transmittance to 28%. At a high cell density, the output is 173 watts per square meter, and transmittance drops to just 11%. Finally, at full opacity, the system reaches 180 watts per square meter, with no visible light transmittance. These design variables play a crucial role in the performance of the product. Depending on the design intent, solar cells can be fully exposed so that they can be seen, or they can be hidden partially or almost entirely, creating a uniform color that resembles a conventional facade material. It's important to note that adding a frontal color will diminish the light transmittance of the frontal glass. Specifications of our PV glass. Our PV glass is available in a range of sizes, offering flexibility to suit various project needs. For instance, the sizes range from 750 by 750 to 2000 by 4000 millimeters. The thickness of the PV glass can vary, depending on the size and specific needs of the project. Configurations include options such as 4+4, 4+6, 6+6, 8+8, 10+10, and 12+12 millimeters. The lightest option, 4+4 millimeters, weighs 20 kilograms per square meter, while the heaviest, 12+12 millimeters, weighs 60 kilograms per square meter. For raised access photovoltaic floor tiles, the available sizes range from 750 by 750 to 3000 by 2000 millimeters. The thickness options for these tiles include 8+8, 10+10, and 12+12 millimeters. The lightest, 8+8 millimeters, weighs 40 kilograms per square meter, while the heaviest, 12+12 millimeters, weighs 60 kilograms per square meter. Amorphous silicon technology. Now, let's discuss amorphous silicon technology. This technology ranges from fully opaque, which provides higher nominal power, to various levels of light transmittance, allowing daylight penetration while maintaining unobstructed views. Onyx Solar's semi-transparent PV glass also effectively filters out harmful radiation, including ultraviolet and infrared rays. However, it's important to note that while amorphous silicon glass offers clear views, its power capacity is 3 times lower compared to crystalline silicon glass. Crystalline silicon, therefore, offers a greater return on investment and more clean power, making it a more efficient choice. Relationship between cell density and VLT. For the amorphous silicon technology, when the cell density is low, reaching 28 watts per square meter, the glass allows about 30% of visible light to pass through. As we increase the cell density to a medium level, reaching 34 watts per square meter, the visible light transmittance drops to 20%. When we have a high cell density, reaching 40 watts per square meter, the amount of light passing through decreases further to just 10%. Finally, at maximum cell density, where the glass reaches 57 watts per square meter, the glass becomes completely opaque, blocking all visible light with a transmittance of 0%. Sizes and configurations of our PV glass. Our PV glass comes in a variety of sizes and configurations to meet the needs of different projects. The available sizes range from 600 by 300 to 1,245 by 635 millimeters. For these dimensions, the double laminated PV glass can be configured with either 3 plus 4 millimeters of tempered glass, weighing 17 kilograms per square meter, or 3 plus 5 millimeters of tempered glass, with a weight of 22 kilograms per square meter. For larger PV glass installations, sizes range from 600 by 300 up to 4,000 by 2,000 millimeters. We offer 3-ply laminated configurations, including options like 4 plus 3 plus 4 millimeters, which weigh 30 kilograms per square meter, up to 8 plus 3 plus 8 millimeters, weighing 52 kilograms per square meter. There are also intermediate choices, such as 5 plus 3 plus 5 and 6 plus 3 plus 6 millimeters. For raised access photovoltaic floor tiles, which range in size from 600 by 600 to 3,000 by 1,500 millimeters, we offer a 3-ply laminated configuration of 6 plus 3 plus 6 millimeters, weighing 42 kilograms per square meter. Our technical department is available to assist you in selecting the appropriate configuration based on the specific size required for your project. We also provide custom double glazing options to meet the unique demands of your design. Please feel free to reach out to inquire about available thickness and size configurations to ensure the best outcome for your project. For more technical information, please refer to our technical guide available on our website. Chapter 5. Optical, Thermal, and PV Properties for Examples Selected. When selecting crystalline silicon photovoltaic glass for your project, it's essential to understand how different configurations can impact both energy performance and light transmittance. To illustrate this, let's compare two examples of double laminated insulated glass, one with a high-density cell configuration and the other with a low-density configuration. Keep in mind, these are just two of the many options available, each offering distinct benefits depending on your project's needs. Starting with the high-density configuration. In the first example, we have a glass installation with a single 12mm air chamber and a low-E coating. This setup reaches a nominal power of 173 watts peak per square meter. However, because of the high cell density, the visible light transmittance is only 11%, meaning that very little light passes through the glass. The solar factor is 6%. The thermal insulation, indicated by the U value, stands at 1.60 watts per square meter Kelvin, or 0.28 British thermal units per hour per square foot per degree Fahrenheit. The external light reflection is 8.3%. Now, if we enhance this high-density glass by incorporating two 12mm argon chambers and two low-E coatings, the power output remains the same at 173 watts per square meter. However, the U value improves significantly to 0.70 watts per square meter Kelvin, or 0.12 British thermal units per hour per square foot per degree Fahrenheit, which means better insulation and energy efficiency. Despite these changes, the VLT, solar factor, and light reflection values remain constant at 11.6 and 8.3%, respectively. Next, let's explore the low-density configuration. In this example, the glass installation also has a single 12mm air chamber with a low-E coating, but because of the lower cell density, its nominal powers stands at 111 watts peak per square meter, which is less power compared to the high-density version. However, this lower density allows for a higher visible light transmittance of 43%, letting much more natural light into the building. The solar factor is also higher at 22%. The U value here is the same as in the high-density version at 1.60 watts per square meter Kelvin, or 0.28 British thermal units per hour per square foot per degree Fahrenheit. Light reflection remains consistent at 8.3%. If we then enhance this low-density glass with two 12mm argon chambers and two low-E coatings, the U value improves to 0.70 watts per square meter Kelvin, or 0.12 British thermal units per hour per square foot per degree Fahrenheit, matching the improved thermal insulation seen in the high-density version. The nominal power remains at 111 watts peak per square meter, and the VLT, solar factor, and light reflection remain unchanged at 43.22 and 8.3%, respectively. In summary, the high-density configuration is ideal if your goal is to maximize energy generation, as it provides higher power output. However, it also significantly reduces the amount of natural light that can pass through the glass. On the other hand, the low-density configuration strikes a balance between energy generation and light transmittance, making it a suitable choice for environments where both natural light and energy efficiency are important. Moreover, the improvement in the U-value with the dual 12mm argon chamber configuration, which is evident in both high and low-density glass, indicates enhanced thermal insulation, making this option particularly effective for maintaining indoor temperature control while optimizing energy efficiency. To learn more about the potential energy production of our photovoltaic glass in any specific location, we invite you to use our PV estimation tool. Simply scan the QR code provided in our catalog or visit our website to access this tool. It allows you to calculate the amount of energy that can be generated by our glass, tailored to your unique environment and conditions. When evaluating amorphous silicon photovoltaic glass, it's important to consider how different transparency levels impact both energy generation and light transmittance. Let's compare two examples of double laminated insulated glass, one with low transparency and the other with high transparency. These examples will help illustrate the differences, though it's important to remember that there are many other configurations available to suit various project needs. Starting with the low transparency configuration. In this example, the glass installation is equipped with a single 12mm air chamber and a low E coating. Due to its low transparency, its nominal power is 40 watts peak per square meter. The visible light transmittance is only 10%, as well as the solar factor. The U value stands at 1.60 watts per square meter Kelvin, or 0.28 British thermal units per hour per square foot per degree Fahrenheit. The external light reflection is at 7.3%. When this low transparency glass is upgraded with two 12mm argon chambers and two low E coatings, the nominal power remains at 40 watts peak per square meter. However, the thermal insulation improves significantly, as indicated by the U value dropping to 0.70 watts per square meter Kelvin, or 0.12 British thermal units per hour per square foot per degree Fahrenheit. The VLT, solar factor, and light reflection remain consistent at 10, 10, and 7.3%, respectively. Now, let's explore the high transparency configuration. In this scenario, the glass installation also features a single 12mm air chamber with a low E coating. However, due to its higher transparency, it has a lower nominal power, 28 watts peak per square meter. The visible light transmittance is significantly higher at 27%, allowing much more natural light to enter the building. The solar factor here is 17%, which is higher than in the low transparency configuration. The U value for thermal insulation remains the same as in the low transparency version. The light reflection is slightly reduced at 7.1%. When this high transparency glass is enhanced with two 12mm argon chambers and two low E coatings, the U value improves to 0.70 watts per square meter Kelvin, or 0.12 British thermal units per hour per square foot per degree Fahrenheit, mirroring the improvement seen in the low transparency version. The nominal power remains at 28 watts peak per square meter, and the VLT, solar factor, and light reflection stay constant at 27, 17, and 7.1%, respectively. In summary, the low transparency glass configuration is ideal for applications where maximizing energy generation is critical, as it provides higher power output, though it allows less natural light to pass through. On the other hand, the high transparency configuration strikes a balance between both, making it more suitable for environments where daylight is a priority. Both configurations show improved thermal insulation when upgraded with dual 12mm argon chambers, as indicated by the lower U value. This enhancement makes either option particularly effective in maintaining indoor temperature control while optimizing energy efficiency. As you continue to explore the best options for energy-efficient design, don't forget to take advantage of our U-value calculation tool. Simply scan the QR code found in our catalog to calculate the U value of any glass configuration, ensuring that your project meets the highest standards of thermal performance. For more information and additional resources, please visit our website or contact our technical team. We're here to assist you in creating innovative and sustainable solutions for your architectural projects. Chapter 6. Customize your photovoltaic glass. Onyx Solar presents a fresh opportunity to incorporate solar energy in locations such as facades or skylights, thanks to the attractive appearance of photovoltaic glass. Contrasting with conventional solar panels, often confined to rooftops, this technology offers a new aesthetic and efficient way to embrace solar energy. A defining characteristic of Onyx Solar is our flexibility in design. Our PV glass is 100% customizable in terms of size, shape, thickness, color, degree of transparency, and finishes. Size, shape, and thickness. Our photovoltaic glass can be fully customized to meet the specific requirements of any project. Onyx Solar's glass panels can be as large as 4,000 millimeters by 2,000 millimeters, which is about 157 by 79 inches, and they are available in both double or triple ply laminated glass. Furthermore, most of our PV glass is designed to be compatible with all types of insulated glass units, or IGUs, ensuring versatility and seamless integration in a wide range of architectural applications. Color, finishes, and cells visibility. Depending on the design intent, solar cells can be fully exposed so that they can be seen. Otherwise, they can be hidden partially, or almost totally, creating a panel that displays a uniform color and looks like a conventional building material. Color freedom. Our photovoltaic color product portfolio, developed over 2 years by our R&D team, offers a unique blend of aesthetics, chromatic variety, and optimized performance. After rigorously testing over 200 different colors and shades, we have selected 16 final colors for our product portfolio. These were chosen for their excellent balance between color quality and energy output. Additionally, all of these colors are designed to be fade and scratch resistant, ensuring long-lasting finishes. Consult with us, all colors available. Chapter 7. Feasibility Studies. Economic and environmental benefits. Customized feasibility. Studies for your specific project. PV glass optimizes insulation, reducing HVAC energy usage. Its transparent version harnesses natural light, minimizing reliance on artificial illumination. These passive properties alone significantly cut energy consumption, while its active capability for clean power generation makes it ideal for net zero construction and achieving high financial return. When we talk about net zero buildings, we are referring to a type of construction that balances the amount of carbon it emits with the amount it offsets or absorbs over a specified period, ultimately achieving net zero carbon emissions. Onyx Solar offers customized feasibility studies for each customer, demonstrating how photovoltaic glass can contribute to their buildings. The feasibility studies include comprehensive information about the product's economic and environmental impact on the project. Onyx Solar's ROI and payback time calculation involves comparing the cost of PV glass with alternatives such as conventional glass. This calculation also takes into account the overall system costs, including electrical installation. Furthermore, the long-term value of the energy generated by the PV glass, along with potential tax credits and incentives, is thoroughly assessed to provide a comprehensive financial overview for the project. Furthermore, the long-term value of the energy generated by the PV glass, along with potential tax credits and incentives, is thoroughly assessed to provide a comprehensive financial overview for the project. In addition, we provide a comprehensive set of calculations to contextualize the value of the kilowatt-hour produced, including the number of light points that can be illuminated by the generated energy. Considering the average internal rate of return that Onyx Solar's PV glass offers to building owners, our technology indeed presents a remarkable investment opportunity in the long run. The consistent and favorable returns from photovoltaic glass installations position it as an attractive and lucrative choice for investors seeking sustainable solutions that also provide financial gains. The average payback time for our photovoltaic glass is less than 4 years. You can expect an average return on investment of over 20% per year, with an energy payback period of just 2 years. Standardized feasibility studies in 200 locations. We offer standardized feasibility studies in over 200 locations worldwide. To access these studies, along with ROI analyses for more than 200 cities around the globe, simply scan the QR code provided in our catalog, which you can find on our website. These studies include a range of available construction solutions, taking into account factors like inclination and orientation. This comprehensive overview will help you understand how our photovoltaic solutions can be seamlessly integrated into projects that are specific to your city. 30% tax credit. Faster return on investment. More profitability. The investment tax credit incentivizes building integrated photovoltaic installations by covering 30 to 50% of the cost. Solar windows, shingles, or facades, which provide a dual function, are eligible for this ITC. It covers not only the cost of the PV glass, but also the supporting metal structures, all balance of system and labor. This tax credit can be sold in the market to anticipate the cash and is independent of your tax filing. Fight climate changes in two decisive fronts. The real estate sector accounts for 39% of global greenhouse gas emissions, with 11% attributed to building materials and processes. The industry seeks net zero energy facilities or reduced carbon footprints. As such, photovoltaic glass emerges as a strategic building material in achieving these goals. At Onyx Solar, we are proud to fight climate change with our initiative number 1 Meter 1 Tree, through which we will plant 1 tree for every square meter of photovoltaic glass that we manufacture. We promote carbon capture with the plantation of thousands of trees around the planet, since trees are the most efficient absorption machine created by nature. This let us fight against the climate change in two fronts: preventing the emissions of CO2 into the atmosphere with the installation of energy-generating photovoltaic glass. Capture existing CO2 from the atmosphere by planting trees. What do green building materials contribute to? According to the World Green Building Council, these materials can significantly enhance the value of a building, increasing it by 5 to 7%. They also help to raise occupancy rates by 3.5%. and increase rents by 3%. Additionally, green building materials enhance lease tenancy, making them a valuable investment for any property. Chapter 8. Projects. Facades. From here, we will explore the various architectural structures where Onyx Solar's photovoltaic glass has been integrated. We'll look at different types of structures, including facades, skylights, walkable floors, canopies, Brise Soleil, balconies, and railings. Within each category, we'll dive into specific projects from around the world, demonstrating how our architectural PV glass, whether crystalline or amorphous, has been tailored to meet the unique challenges and requirements of each design. As we go through each section, you'll discover the versatility of our PV glass and how it has been adapted to enhance both the functionality and aesthetics of buildings across the globe. Crystalline silicon facades. Amat Beit Havard in Tel Aviv, Israel. Onyx Solar's groundbreaking white crystalline silicon PV glass was installed in this building located in Tel Aviv as part of a sustainable renovation of an existing office. In this innovative project, Onyx Solar introduced its hidden PV building materials, which cleverly conceals solar cells within the surface of the glass, resulting in a white appearance while keeping the solar cells entirely invisible. This innovation allows for a seamless integration of solar technology into building facades. The glass is available in different colors, including white, corten steel, and many others catering to various architectural preferences. In this case, the white solar PV installed in the facade covers around 600 square meters and generates 10% of the building energy needs. Let's go through the technical data of this project. Its nominal power reaches 124 watts peak per square meter, and its light reflection is 8%. Gioia, 22, in Milan, Italy. Continuing one of the largest urban regeneration efforts in Europe, Gioia 22 is a landmark office tower in Milan's business district. As Italy's first nearly net-zero building, Gioia 22 advances fresh perspectives and progress in a city known for its innovative spirit. Developed by Coima and designed by Pelli Clark and Partners, Gioia 22 exceeds Milan's energy regulations by 15%. Using on-site renewable energy sources, including 6,000 square meter of crystalline PV glass panels installed on the facade, which generate 65% of the energy required for heating and cooling. The facade system, which count with around 800 kilowatt peak installed, was developed together with Permastilisa, a leading global contractor of architectural envelopes responsible of the most iconic facades of the world. Let's take a moment to review the technical data. The nominal power reaches 158 watts peak per square meter. The visible light transmittance is 5%, with a solar factor of 12%, and an external light reflection of 8%. This project has been widely recognized for its innovation, winning the Facade 2022 award, and it has received the prestigious LEED Platinum certification, the highest level of recognition for sustainable buildings. Gioia 22 is more than just a building. It's a symbol of how architectural quality and environmental sustainability can no longer be separated. As Milan City Councillor for Urban Planning Pier Francesco Maran stated, "This project shows once again how architectural quality can now no longer be separated from environmental sustainability." To learn more about this project, you can scan the QR code available in our catalog or visit our website for detailed technical data and videos. Sterling Bank in Lagos, Nigeria. Originally constructed in the 1980s, this bank's headquarters underwent an innovative refurbishment by integrating a second skin with photovoltaic technology, which offers a contemporary design while ensures a sustainable and robust supply of clean energy for its employees. The facade now also filters harmful radiation and heat to achieve huge savings in cooling. The installation features 3,250 photovoltaic glass panels, which cover an area of 6,500 square meters and achieve 1 megawatt of installed power. This groundbreaking project achieved a great milestone when it was made as the largest photovoltaic integration on the African continent. Each PV glass unit measures 2,000 by 1,000 millimeter and features a blue ceramic frit to align with Sterling Bank's aesthetic requirements. Let's dive into the technical details. The PV glass reaches a nominal power rating of 159 watts peak per square meter. The solar factor, or SHGC, is 29%. Lastly, the exterior light reflection of the PV glass is 8%. ESCCA Business School in Bordeaux, France. This project is situated in a historical military site from the 18th century, where it was essential to conserve the Napoleonic facades. It is located at the campus of a leading French business school, ESCCA. For this project, we adapted our product to create a solution that was not only energy efficient, but also aesthetically harmonious with the historical environment as customer required from us. Onyx Solar provided photovoltaic glass in opaque white color. It was made with crystalline technology, but cells are totally hidden, so they become invisible. The project required a light solution, so the PV glass was laminated with Tedlar and complemented with an aluminum frame for increased rigidity. The PV glass reaches a nominal power rating of 92 watts peak per square meter. The solar factor, or SHGC, is 34%, and the exterior light reflection of the PV glass is 8%. To learn more about this project, you can scan the QR code available in our catalog or visit our website for detailed technical data and videos. Balenciaga store in Miami, United States. Balenciaga incorporated a photovoltaic curtain wall into its flagship store in the vibrant Miami Design District. This innovative installation features hurricane-resistant photovoltaic insulating glass units crafted from crystalline silicon PV solar cells, reflecting the deeply held conviction of François-Henri Pinault that luxury and sustainability are one and the same. Sustainability is at the heart of Kering's strategy, as much as its creative and modern vision of luxury. This installation is perfectly aligned with Kering Group's commitment to innovation and carbon footprint reduction across its stores. The polycrystalline PV glass at Balenciaga's Miami flagship store was made in a chic pale blue hue, adding a fashionable touch to the storefront. Each PV glass panel has a nominal peak power of 138 watts, contributing to a total system that generates over 7,700 kilowatt-hours per year. Balenciaga's fusion of sustainability and style not only elevates its aesthetic appeal, but also sets a noteworthy example of integrating renewable energy solutions in the realm of high-end retail. This project PV glass reaches a nominal power rating of 101 watts peak per square meter, with a visible light transmittance of 24%. The solar factor, or SHGC, is 18%. For thermal insulation, the U value is 2.74 watts per square meter Kelvin, or 0.48 in British thermal units per hour per square foot per degree Fahrenheit. Additionally, the exterior light reflection is 8%. Geelen Counterflow in Heelen, Netherlands. Located in the Netherlands, this project features photovoltaic glass manufactured using monocrystalline 5BB technology. The glass has large dimensions of up to 3,829 by 1,994 millimeters, a double 12 millimeters argon chamber, and a total thickness of 60 millimeters, with an individual weight of 630 kilograms, making it the heaviest glass manufactured by Onyx Solar to date. The Geelen Counterflow office building in Heelen, Netherlands, received a 5-star rating on the BREEAM NL certification system after expanding its headquarters. This building expansion, designed by Architecten en Bouwmeesters and built in 2014, holds the title of the most sustainable office worldwide, with a BREEAM score of 99.94%. Let's go through the technical data of this project. Its nominal power reaches 95 watts peak per square meter. Its VLT is 51%, with a solar factor of 23% and a U value of 0.70 watts per square meter, Kelvin, or 0.12 in British thermal units per hour, per square foot per degree Fahrenheit. Lastly, the light reflection is 8%. Campus Acciona in Madrid, Spain. Onyx Solar has supplied its solar photovoltaic glass to be installed as rain screen cladding at the Acciona campus, the new headquarters of this titan in Madrid. Acciona is a multinational conglomerate dedicated to the development and management of infrastructures and renewable energy with operations in 63 countries. The Acciona campus is a complex of more than 70,000 square meters that includes several buildings, green areas, and services. The project was designed by Fenwick Iribarren Architects with the aim of creating a sustainable, innovative, and transparent campus. Our solar photovoltaic glass contributes to improve the energy efficiency, the thermal and acoustic insulation, the indoor comfort, and the aesthetics of the building where it was installed, generating clean and free energy from the sun. Its nominal power reaches 162 watts peak per square meter. The solar factor is 37%, and the light reflection is 8%. Block in Querétaro, Mexico. The Querétaro block represents a milestone in technological advancement in Mexico, establishing itself as the new Bloqué Center for Creative Innovation and Technology in Querétaro. This exceptional complex will position the city as the premier digital technology hub in Latin America. Reflecting its cutting-edge nature, the building integrates advanced solutions such as over 3,700 photovoltaic glass units from Onyx Solar across its 4 facades. These panels offer a total installed capacity of 505 kilowatt peak, allowing the complex to achieve more than 40% energy independence. They generate over 458,000 kilowatt-hours annually, making it the largest photovoltaic wall in Latin America. The photovoltaic glass integrates crystalline silicon cells with blue-tinted glass, creating a visually striking effect. This not only highlights the building's commitment to renewable energy, but also provides a distinctive blue hue to its facades. Additionally, the installation of Mexico's first 3D screen ensures the building draws significant attention. Turning to the technical details, the nominal power reaches 104 watts peak per square meter. It offers a visible light transmittance of 39%, allowing a significant portion of light to pass through. The solar factor, or SHGC, is 23%. The U value, reflecting thermal insulation, stands at 5.4 watts per square meter Kelvin. Additionally, the exterior light reflection is less than 6%. To learn more about this project, You can scan the QR code available in our catalog or visit our website for detailed technical data and videos. Sensoria Tower in Dubai, United Arab Emirates. Five Holdings is a Dubai-based vertically integrated real estate development and hospitality group. It owns, among other brands, Pacha. Five hotels and resorts focus on developing high-quality properties while providing top entertainment and luxurious lifestyle experiences to their guests in world-class sustainable properties built with state-of-the-art technology. Onyx Solar provided its energy-generating building materials for an innovative 4,400 square meter ventilated facade system installed on Sensoria Tower in Dubai. This facade produces a huge amount of clean power thanks to the sun and provide unbeatable thermal insulation to ensure the comfort of Sensoria's customers. This laminated safety glass was produced in white and gray colors and incorporated our technology and know-how to hide crystalline silicon PV cells to create pieces with a totally homogeneous surface that harvest a huge amount of clean energy from the sun. The facade was built with triangular-shaped PV glass panels to create a visually 3D facade that resembled the aesthetic of a large soundproof foam pattern, a clear statement of Five's commitment to sustainability and fun. This visually textured facade was made with colored PV triangular material that was 3,280 mm long and 1,643 mm high. Cebu Tower in Cebu, Philippines. The tower is the new regional headquarters in the Philippines of a confidential client. The 20-floor building sits in the heart of Cebu's historic Fuente Osmeña Circle, and it stands as a prominent landmark near the city's cultural center. The design of the tower includes innovative and sustainable design practices to achieve Green Mark certification. As part of these sustainable concepts, the building features 1,100 square meters of PV glass on the facade, manufactured by Onyx Solar. This glass includes crystalline silicon cells and is made with semi-transparent blue glass. It incorporates IGU and low-E coating to optimize the building's thermal insulation and filter harmful radiation while generating renewable energy on-site. The tower features 5 levels of underground parking, a 6-level podium with mezzanines, a lobby, cafe, and a retail branch. It also includes a training and business center, gym, and clinic. Other levels include office spaces and tenant floors for leasing. The 20th floor serves as a public art gallery. Amorphous silicon facades. Dubai Frame in Dubai, United Arab Emirates. The Dubai Frame is an impressive architectural wonder, standing 150 meters tall and 105 meters wide in Zabil Park, Dubai. With over 2 million visitors enjoying its breathtaking views of the city's architectural gems, it quickly became a notable attraction after its completion in 2015. Onyx Solar played a pivotal role in this project by integrating 1,200 square meters, or 12,916 square feet, of amorphous silicon PV glass into the building's facade. Approximately 2,500 PV glass panels were used. These panels, with a yellow-gold finish and a 20% see-through degree, constitute a 38 kilowatt peak DC system. This system significantly offsets the building's energy demand by harnessing clean, free solar energy. This PV glass not only showcases design flexibility by offering customizable color options, but also aligns with the original architectural vision. Beyond energy generation, its properties include filtering UV and IR radiation, enhancing thermal comfort within the building. Now, focusing on the technical specifications, our PV glass for this project's nominal power reaches 34 watts peak per square meter. The VLT is 16% and the solar factor, or SHGC, is 12%. Additionally, it reflects 8% of external light. If you'd like to learn more about this project, you can scan the QR code in our catalog or visit our website where detailed technical data and videos are available. Sea Towers in Barcelona, Spain. The Sea Towers complex in the 22 at District of Barcelona stands as the third building in Spain to achieve the esteemed LEED Platinum certification. This recognition stems from its sustainable and innovative design, leveraging green technologies like photovoltaic glass. These towers boast remarkable energy efficiency, achieving a 52% energy saving. Onyx Solar's solar PV glass adorns the curtain wall of the C-towers, comprising 1,520 square meters of amorphous silicon photovoltaic glass, customized in various dimensions. Each insulating glass unit incorporates a 12 mm air chamber, enhancing the building's thermal and acoustic insulation. In addition, the PV glass manufactured allows the entrance of a good amount of natural light and filter harmful radiation to maximize the comfort inside the building. Situated in the heart of Barcelona's 22 district, a prominent technological and digital hub, the C-towers underscore the city's position as a significant global tech destination. Let's go over the key technical details for this project. Its nominal power reaches 34 watts peak per square meter. The visible light transmittance is 20%. The solar factor, or SHGC, is 32%, and the U value, indicating thermal insulation, is 1.30 watts per square meter Kelvin, or 0.23 in British thermal units per hour per square foot per degree Fahrenheit. Additionally, the exterior light reflection is 8%. For more details on this project, feel free to scan the QR code in our catalog or visit our website, where you can find comprehensive technical data and videos. Coca-Cola, or FEMSA headquarters in Mexico. Onyx Solar supplied photovoltaic glass to the FEMSA headquarters in Monterrey, which stands as the largest Coca-Cola bottler globally. The project involved installing a second skin facade composed of amorphous silicon photovoltaic glass. The installation comprised laminated PV glass panels, blending both fully opaque and semi-transparent panels in line with the facade's design. Its nominal power reaches 38 watts peak per square meter. It has a 20% of visible light transmittance, a solar factor of 34%, and lastly, a 8% of light reflection. Chapter 9. Projects. SKYLIGHTS. Crystalline Skylights. Novartis campus in New Jersey, United States. Novartis's 2,500 square meters, or 26,900 square feet, photovoltaic skylight was installed as a second skin at the new headquarters of the Novartis Pharmaceutical Company in New Jersey, USA. The project comprises 8,020 photovoltaic glass units, each measuring on average 1,511 by 1,931 millimeters, or 4.95 by 6.3 feet. The PV glass was manufactured using perforated crystalline silicon solar cells, which allow natural light to enter the building. This skylight is designed to open and close for maintenance purposes. The total system size is 295 kilowatt peak, and it produces about 273,000 kilowatt-hour per year. This output is sufficient to power over 600 homes annually and helps prevent the emission of early 185 tons of CO2 into the atmosphere. Regarding the technical details, the nominal power reaches 95 watts peak per square meter. The visible light transmittance is 20%, and the solar factor, or SHGC, is 34%. Finally, the external light reflection is 8%. Miami Heat Stadium in Miami, United States. The new eastern entrance of the FTX Arena features an impressive 30,000 square feet canopy that incorporates 14 circular skylights made with crystalline silicon PV glass from Onyx Solar. It is called the Xfinity Plaza and creates a unique amusement space for all fans to enjoy. A total of 300 photovoltaic glass panels were manufactured for this project, which produce 35,000 kilowatt-hour per year and prevent the emission of 20 tons of CO2 into the atmosphere. The arena became the first sports and entertainment center in achieving LEED Gold certification. In this project, the nominal power reaches a 100 watts peak per square meter. The visible light transmittance is 30%, allowing nearly a third of the light to pass through. The solar factor is 34%. And finally, the external light reflection is 8%. For more details on this project, feel free to scan the QR code in our catalog or visit our website, where you can find comprehensive technical data and videos. Convention Center in Edmonton, Canada. Onyx Solar manufactured crystalline silicon insulating photovoltaic glass units to replace the 35-year-old glazing atrium of the Edmonton Conference Centre in Canada. The project involved custom engineering PV glass to fit the current metal structure, integrating 125 different glass types of different dimensions, shapes, and cell layouts. This upgrade allows the building to generate an on-site 230,000 kilowatt-hour per year, which substantially reduces operational and maintenance costs while enhancing thermal insulation and letting in a large amount of sunlight. The PV glass incorporates a 16mm chamber to insulate the building, and the density of cells was totally customized to allow the entrance of a substantial amount of natural light. The atrium's lower section showcases a large circular area displaying a poem in Morse code. The layout of the solar cells was meticulously designed to form verses of the poem. About the technical specifications, in this case, its nominal power reaches 120 watts peak per square meter, with a visible light transmittance of 42% and a solar factor of 50%. For thermal insulation, the U value is 1.30 watts per square meter Kelvin, or 0.23 in British thermal units per hour per square foot per degree Fahrenheit. And lastly, the external light reflection is 8%. To learn more about this project, you can scan the QR code available in our catalog or visit our website for detailed technical data and videos. Oilfield Research Center in Dhahran Techno Valley, Saudi Arabia. The PV integration made in the NESR's Oilfield Research and Innovation Center in Dhahran Techno Valley in Saudi Arabia marks a significant step towards sustainable energy integration in buildings. Featuring an argon chamber, the PV glass units offer thermal insulation and energy efficiency, ideal for Saudi Arabia's hot climate. This technology not only generates clean energy, but also ensures comfortable indoor temperatures, enhancing the complex's sustainability. The photovoltaic skylight produces about 135,000 kilowatt-hour per year and also contributes significantly to users' comfort as our glass filters out ultraviolet and infrared radiation while allowing natural light to pass through. The skylight, with its unique curved shape, involved the fabrication of over 200 different glass shapes to meet the architect's requirements. Additionally, the project includes a carport that provides shade to vehicles and generates 70,000 kilowatt-hour per year, further contributing to the facility's sustainable energy goals. Its nominal power reaches 138 watts peak per square meter. The visible light transmittance is 31%. The solar factor is 25%, and for thermal insulation, the U value is 1.60 watts per square meter Kelvin, or 0.21 in British thermal units per hour per square foot per degree Fahrenheit. Lastly, the external light reflection is 8%, indicating the percentage of light that is reflected off the surface. For more details on this project, feel free to scan the QR code in our catalog or visit our website, where you can find comprehensive technical data and videos. Avena Industrial Building in Mexico. Onyx Solar successfully completed a 2,900 square meter project for the new industrial facility of Avena Cosmetics in Mexico. The design of the manufactured PV glass was fully customized to achieve the objectives set by the client. The PV glass installed in this enormous skylight allows the entrance of a large amount of natural light, which will enable Avena to avoid the use of artificial light during the day. In addition, the chosen glass filters a good part of the heat and harmful radiation, while, of course, allowing Avena to generate a large amount of renewable energy on site. Its nominal power reaches 107 watts peak per square meter. The visible light transmittance is 38%, which means a significant amount of light passes through. The solar factor is 0.30, and for thermal insulation, the U value is 5.4 watts per square meter Kelvin, or 0.95 in British thermal units per hour per square foot per degree Fahrenheit. Lastly, the external light reflection is less than 8%. Amorphous silicon. Bell Works Labs in New Jersey, United States. As part of the comprehensive revitalization former Bell Labs facility into the iconic mixed-use Metroburb in New Jersey, Onyx Solar provided 5,575 square meters, or 60,000 square feet, amorphous silicon photovoltaic architectural glass panes. This installation facilitated the creation of the largest photovoltaic skylight of its kind in the USA. The PV skylight both naturally illuminates the complex, while it generates free, clean electricity from the sun. It currently offsets around 60 tons of annual CO2 emissions, drastically improving the building's energy efficiency and reducing its carbon footprint. Utilizing state-of-the-art technology, Bellworks Skylight features 24 different sizes of glass to cover the multiple skylight opening of Eero Saarinen-designed architectural gem. Each glass panel is comprised by amorphous silicon-thin film photovoltaic active glass, laminated between two sheets of tempered glass. The PV glass provides exceptional light transmittance while simultaneously achieving an optimal solar heat gain coefficient, enabling the building to offset HVAC requirements and maintain its distinctive design. Originally constructed in 1962, the building is revered for its role in spurring the development of some of the world's foremost inventions and research concepts, including the first practical solar cell. Furthermore, it was home to 7 Nobel Prize Award winners. Let's go over the technical details. Its nominal power reaches 34 watts peak per square meter. The VLT is 16%, allowing a small amount of light to pass through. The solar factor is 32%, and the external light reflection is 8%. I&M Bank in Nairobi, Kenya. The largest photovoltaic skylight in Africa became a reality at the new I&M Bank headquarters in Nairobi, Kenya. It is made up of 2.2 thousand square meters of amorphous silicon-laminated PV glass panes, with varying degrees of transparency and various dimensions tailored to meet the project's design requirements. This PV skylight serves as a natural light source that filters harmful radiation and heat to ensure the comfort of the bank's employees and visitors. On top of that, the glass constitutes a stable source of renewable energy sufficient to illuminate more than 6,500 light points inside the building. All this contributes significantly to reducing the environmental impact associated with energy consumption. Gul Khan, CEO of I&M Bank, commented, and quote, "This beautiful new building is a state-of-the-art green design building with integrated photovoltaic glass installation, one of a kind in East and Central Africa. The building is a Grade A office development with environmentally conscious design." Now, this project nominal power reaches 34 watts peak per square meter, with a visible light transmittance of 16%. The solar factor is 32%, and lastly, the external light reflection stands at 8%. Valladolid University in Valladolid, Spain. Lucia Building is an applied research center located at the University of Valladolid. It won the distinction of being the most sustainable building in Europe and the entire Northern Hemisphere in 2015, owing to its energy-efficient design and architectural ingenuity. 2 central photovoltaic atriums crafted from see-through amorphous silicon PV laminated safety glass allow the entrance of natural light into the building. The PV glass was manufactured with a low-E coating and an argon spacer, significantly enhancing the building's thermal performance. This building achieved LEED Platinum certification along with 5 leaves in certification Verde. In this project, the nominal power reaches 40 watts peak per square meter. The visible light transmittance and the solar factor are both 10%. For thermal insulation, the U value is 1.60 watts per square meter Kelvin, or 0.28 in British thermal units per hour per square foot per degree Fahrenheit. Lastly, the external light reflection is 8%. CenterNovel Therapeutics, University of California, United States. A partnership between Biomed Realty, the University of California, and the design team of Perkins Will led to the award-winning Center for Novel Therapeutics. The atrium allows the massive entrance of natural light inside the building and constitutes an important source of clean energy. The insulated PV glass units installed incorporate a 12 mm air chamber that offers a great thermal insulation throughout the whole year, reducing the need for heating and cooling. In this project, the nominal power reaches 34 watts peak per square meter. Its visible light transmittance is 16%, with a solar factors of 12% and a U value of 1.60 watts per square meter Kelvin, or 0.21 in British thermal units per hour per square foot per degree Fahrenheit. Finally, its light reflection is 8%. ING Direct Bank in Madrid, Spain. ING is one of the largest online banks of the world. They integrated ASI photovoltaic glass panes in the central atrium located in their offices in Madrid. This skylight is capable of generating a sufficient amount of energy to feed over 700 light points throughout the building, thus preventing the release of tons of CO2 into the atmosphere. Besides energy generation, the PV glass panes supplied filter harmful radiation and heat, while also allowing the natural light to pass through to ensure the comfort of workers and visitors. As Steven van Rijswijk, CEO of ING Bank said, ING aims to put sustainability at the heart of what we do, defining new ways of doing business where the planet is just as important as economic growth. Our buildings and data centers align with the low-carbon economy of the future. Turning our attention to the technical specifications, the nominal power reaches 34 watts peak per square meter. It has a visible light transmittance of 16%. The solar factor is 32%, and the external light reflection is 8%. Chancery Lane in London, United Kingdom. McLaren successfully delivered this development located in Chancery Lane for DRR Consultancy Group, now called Sidara. The new development unite over 1,000 members of staff in a single state-of-the-art workplace. Sidara is home to 17 leading specialist firms in the built environment, including Dar, Perkins and Will, Curry and Brown, Tylen, and Penspin. Its companies have worked on some of the most iconic and challenging projects where the natural environment and humanity coexist. Their office in London placed sustainability at the core of the design, designed to be energy efficient and adaptable to climate change, with increased resilience from features such as the Onyx Solar's PV glass installed in the atrium. Crafted with amorphous silicon solar technology, the PV glass produces clean on-site power and serves as a natural light source, while filtering ultraviolet and infrared radiation. In this project, the nominal power reaches 40 watts peak per square meter. It has a visible light transmittance of 10%, and the solar factor is 12%. For thermal insulation, the U value is 2.70 watts per square meter Kelvin, or 0.48 in British thermal units per hour per square foot per degree Fahrenheit. Finally, the external light reflection is 8%. Chapter 10. Projects, Canopies. Crystalline Silicon, McDonald's restaurant in Orlando, United States. McDonald's unveiled its groundbreaking global flagship on the west side of Disney's theme park in Florida, marking the establishment as McDonald's first zero-energy building in the country. Onyx Solar played an important role in achieving sustainability goals with photovoltaic glass units installed on the outdoor dining patio canopy. The photovoltaic glass canopy over the dining patio is particularly important in this context. It provides critical shade, reducing direct solar heat gain and creating a cooler environment underneath. This feature is vital in a place like Florida, where intense sunlight can significantly increase temperatures. At the same time, the photovoltaic glass generates energy, contributing to the building's zero-energy goal and creating a sustainable, comfortable space for visitors. Let's take a look at the technical specifications. In this project, reaches a nominal power of 118 watts peak per square meter. The visible light transmittance is 39%, allowing a substantial amount of light to pass through. The solar factor is 42%, and lastly, the external light reflection stands at 8%. To learn more about this project, you can scan the QR code available in our catalog or visit our website for detailed technical data and videos. Health Peak Campus in San Diego, United States. The Health Peak Callan Ridge campus in San Diego, California, now boasts an extraordinary architectural addition, a photovoltaic canopy from Onyx Solar, showcasing Building Integrated Photovoltaics solutions. The canopy incorporates crystalline silicon photovoltaic glass in different sizes. Each glass module allows a light transmission between 27% to 30%, effectively converting sunlight into clean and free energy. Complementing the photovoltaic canopy, the project integrates multiple sustainable architectural features, including a green roof, solar panels, and a large canopy, providing shading to reduce heat gain on south-facing glass surfaces. Here, it reaches a nominal power of 135 watts peak per square meter, with a visible light transmittance of 27% and the solar factor of 31%. Lastly, the external light reflection stands at 8%. Microsoft in Nairobi, Kenya. Africa Development Center. The Africa Development Center, housed within Dunhill Towers, represents Microsoft's inaugural engineering offices in Africa. Its rooftop embodies a dual function, harnessing solar energy to generate clean electricity while allowing natural light to permeate through. This photovoltaic glass not only produces free power, but also shields against harmful UV and IR radiation, ensuring a safer and more comfortable environment for Microsoft's employees who utilize this space for breaks and relaxation. Comprising crystalline silicon photovoltaic glass, the installation boasts a peak power output of 27.20 kilowatt peak and features a transparency degree exceeding 23%. Let's dive into the technical specifications. In this project, the nominal power output is 155 watts peak per square meter. They allow 23% of visible light to pass through, and its solar factor is 29%. Finally, the external light reflection stands at 8%. Hewlett-Packard in Barcelona, Spain. Representing one of the globe's largest and most advanced centers for digital printing technology, in HP's new 3D Research and Development Center in Barcelona, Spain, the project involves a photovoltaic canopy crafted from high-density solar cell glass. This design not only offers shade, but also maximizes energy generation capacity. Each PV glass panel measures approximately 2,890 by 730 millimeters, covering a total area of 1,000 square meter. The cumulative system size amounted to 138 kilowatt-hours, allowing the client to offset a substantial portion of its daily energy consumption through sustainable energy generation. Regarding technical specifications, it reaches a nominal power of 129 watts peak per square meter. The visible light transmittance is 33%, allowing about a third of the light to pass through. The solar factor is 40%, and the external light reflection is 8%. Newark International Airport in New Jersey, United States. The new Terminal A at Newark Liberty International Airport is set to replace the existing terminal with a cutting-edge 1 million square foot structure featuring 33 gates dedicated to domestic flights. The terminal's crystalline silicon photovoltaic glass canopy boasts a power output of each glass panel in this system varies, ranging from 228 watts per unit to 381 watts per unit. Comprising 540 photovoltaic glasses available in various sizes, such as 2,134 by 1,677 millimeters and 2,286 by 1,677 millimeters, this system is a testament to adaptable solar energy solutions. The PV glasses, featuring a heat-soak-tested 10 plus 10 millimeters of tempered glass configuration, are designed for both durability and efficiency. Moreover, they provide a 60% transparency degree, striking a balance between energy generation and natural light transmittance. About the technical details, it reaches a nominal power of 82 watts peak per square meter, and the visible light transmittance is 60%. Lastly, the external light reflection is 8%. Mohammed VI University in Ben Guerir, Morocco. This photovoltaic canopy, spanning nearly 600 square meters, or 6,458 square feet, stands at the entrance of the Mohammed VI Polytechnic University. This innovative structure offers a shaded pathway between buildings, providing a much-needed respite from the scorching temperatures often experienced in Morocco. Creating this canopy presented a manufacturing challenge for Onyx Solar due to its size and the required efficiency. Custom-engineered PV glass panes, each boasting 144 crystalline silicon solar cells, were essential, resulting in 626 watt per unit rating. The canopy generates 135,000 kilowatt-hours per year of renewable energy, while curbing CO2 emissions by 100 tons annually. Architects Ricardo Bofill and Elie Mouyal blended modern design with the traditional Arab latticework, preserving the architectural heritage of the region. About the technical details, it reaches a nominal power of 147 watts peak per square meter. The visible light transmittance is 22%, and the solar factor is 25%. Lastly, the external light reflection is 8%. Olympic Port in Barcelona, Spain. Barcelona City Council, alongside Barcelona de Serveis Municipals, Barcelona Regional and Ordaic has renovated 24,000 square meters at Port Olympic. This major project revitalizes the area to enhance training facilities, aquatic sports, and attract entrepreneurs focused on innovation and the circular economy. In anticipation of the America's Cup 2024, the redevelopment will improve connectivity with its surroundings, stimulate maritime economic activity, and reinforce its commitment to the community. Onyx Solar has installed 2,579 square meters of solar canopies featuring 1,194 photovoltaic panels. Each panel provides 344 watt peak of power and 18% light transmission, achieving a total of 410 kilowatt-hour in renewable energy and enhancing comfort on the terraces. Our panels, with 6 mm double glazing and an acid-treated interior, ensure efficient light transmission and effective shadow diffusion. Designed specifically for the project, they guarantee uniform cell distribution and precise adaptation to the space. The installation, carried out in collaboration with Copsisa and Acciona, was meticulously aligned with the project specifications, ensuring seamless integration with the existing structures. Now, the nominal power of this project reaches 159 watts peak per square meter. The visible light transmittance is 18%. The solar factor is 31%, and its thermal insulation, and the U value is 5.2 watts per square meter Kelvin, or 0.92 in British thermal units per hour per square foot per degree Fahrenheit. And lastly, the external light reflection is 8%. Amorphous silicon. Tanjong Pagar in Singapore. Tanjong Pagar is Singapore's tallest building. It is an architectural marvel designed by SOM and built by Samsung that embodies sustainability at its core. The huge photovoltaic canopy, spanning over 2,600 square meters at the building's main entrance, was built with more than 850 units of amorphous silicon PV glass to generate energy in situ and filter harmful radiation to provide shade and comfort to its visitors. The incorporation of photovoltaic glass was vital for the tower's achievement of Green Mark and Platinum LEED certifications. The canopy generates enough energy to power over 7,000 light points within the building. In Singapore's climate, known for its heat and high humidity, BIPV solutions are of crucial importance to achieve energy efficiency and comfort. The nominal power of this project reaches 40 watts peak per square meter. The visible light transmittance is 10%, meaning only a small amount of light passes through. The solar factor is 29%, and the external light reflection is 8%. Chapter 11. Projects. Brise Soleil. Crystalline Silicon. Naturgy offices in Barcelona, Spain. Naturgy headquarters in Spain boasts a design that features a state-of-the-art photovoltaic sunshade system made of crystalline silicon PV glass with a customized cell density to reach a nominal power of 150 watts per square meter. The PV sunshades, mounted horizontally over a second skin facade and facing south, not only provide critical sun control, reducing heat gain and glare inside the building, but also produce clean, free energy, contributing to the building's energy efficiency and sustainability, reaching LEED Gold certification. The strategic south-facing orientation of the sunshades maximizes solar energy capture, making the most of Barcelona's sunny climate. Now, it reaches a nominal power of 150 watts peak per square meter. The visible light transmittance is 21%, and the solar factor is 34%. Finally, the external light reflection is 8%. For more detailed information, be sure to visit our website. Additionally, you can access videos and technical guides by scanning the projects and references QR code. This will provide you with further insights and detailed data on our projects. Amorphous silicon. Freedom Paris, in Paris, France. Onyx Solar's innovative photovoltaic glass has been prominently featured in the Freedom Building, located in Paris, France. Opting for amorphous silicon glass with a 27% visible light transmittance level, the design seamlessly integrates aesthetic appeal with functionality. It allows for unobstructed views while harnessing clean, free solar energy. The nominal power reaches 28 watts peak per square meter. The visible light transmittance is 27%, and the solar factor is 37%. Finally, the external light reflection is 8%. DWR and D-Lab in Dubai, United Arab Emirates. The Dubai Energy and Water Authority R&D Laboratories in Dubai installed a 1,000 square meter double skin of semi-transparent colored photovoltaic glass made in different colors that include green, yellow, and orange to produce energy on-site and insulate efficiently the building, filtering the harmful radiation. The installation of Brise Soleil, or sun shading devices, is particularly crucial in places with hot and arid climate like Dubai. These innovative features enhance the building's energy efficiency while also ensuring a comfortable indoor environment for its visitors, effectively addressing the challenging local weather conditions. The installation of this Brise Soleil was a key factor to achieve LEED Platinum certification. The center focused its work in 4 main areas: solar power, smart grid integration, energy efficiency, and water. Its nominal power reaches 28 watts peak per square meter and a LVT of 26%. The solar factor is 37%, and the external light reflection is 8%. ICSE Educational Center in Las Palmas, Spain. This innovative building, located in Las Palmas, Spain, attained LEED Platinum certification from the U.S. Green Building Council. It serves as the home for a higher education institute and features a striking glass cladding integrating amorphous silicon PV glass on vertical fins that measure nearly 3 meters in height and half a meter in width. These fins generate free and clean power for the institution, while filtering UV and IR radiation, meanwhile allow natural light to pass inside the building. The nominal power of this project reaches 39 watts peak per square meter. The visible light transmittance is 20%, and the solar factor is 32%. Lastly, the external light reflection is 8%. Bursagaz HQ in Bursa, Turkey. Bursagaz is a prominent gas supplier from Turkey that installed an attractive facade made of amorphous silicon PV glass in its headquarters, showcasing a commitment to sustainability and energy efficiency. This installation was a key contributor to achieve the LEED Gold certification. The PV glass, a part of producing electricity, filters UV and IR radiation, meanwhile allows the entrance of natural light in order to maximize the comfort of the Bursagaz's workers. Let's go over the technical specifications. It reaches a nominal power of 49 watts peak per square meter. The visible light transmittance is 10%, meaning that only a small amount of light passes through. The solar factor is 32%, and the external light reflection is 8%. SJD Pediatric Cancer Center in Barcelona, Spain. Onyx Solar supplied colored amorphous silicon PV glass for the SJD Pediatric Cancer Center's FINS system in Barcelona, Spain. The installation consists of medium transparency amorphous silicon glass units that come in 4 different colors and a variety of dimensions and configurations. The selection of soothing, cheerful colors contributes to a welcoming and positive atmosphere, which is vital in healthcare environments, especially those designed for children. This setup not only provides shading, but also improves the building's visual appeal, perfectly aligning with the architectural demands and fulfilling the client's specifications while generating energy in situ, filter the harmful radiation and heat. About the technical information, it reaches a nominal power of 34 watts peak per square meter. A visible light transmittance is 26 and a solar factor of 34%. Lastly, the external light reflection is 8%. To learn more about this project, you can scan the QR code available in our catalog or visit our website for detailed technical data and videos. Life Sciences Building in University of Washington, Seattle, USA. The Life Sciences Building at the University of Washington features custom vertical glass solar fins on its facade. The fins generate enough electricity to light more than 12,400 square feet of the building's office space each year. These first-of-its-kind fins were designed by the leading architectural firm Perkins plus Will that has led for decades the AEC industry toward exceptional environmental performance. The building was constructed by Environmental Performance. The building was constructed by Skanska, one of the main general contractors of the world. Each 3-ply laminated tempered glass fin is installed framelessly and vertically at a 90-degree angle to the curtain wall. Boasting concealed junction boxes and wires, the fins ensure a seamless architectural appearance. Innovative solar glass fins put science on display while generating enough electricity to light all of offices year-round, helping achieve LEED Gold and the AIA 2030 Challenge. Much more than a building, LSB provides the foundation for innovative and collaborative cutting-edge research on climate change. It acts as a hub for student discovery, transforming the way we teach and how the next generation of scientists learn, with sustainability at the core. Jason McLennan, Chief Sustainability Officer, said, and quote, "Most of the world's leading companies and institutions realize now that their license to do business is severely threatened by climate change and loss of ecosystem function. As a result, the urgency to act is more palpable than it was even 2 years ago." Now, let's go through the technical specifications. It reaches nominal power of 40 peak watts per square meter. The visible light transmittance is 10%, and He solar factor is 29%. Finally, the external light reflection is 8%. To learn more about this project, you can scan the QR code available in our catalog or visit our website for detailed technical data and videos. Chapter 12. Projects. Walkable floor. Crystalline silicon. Kirk Capital HQ in Vejle Fjord, Denmark. The shareholders of Kirk Capital are the direct descendants of Ole Kirk Christiansen, the founder of Lego. A total of 446 glass units, varying in shape and size, were utilized for the project to achieve its distinctive circular design. Fjord House sets a new standard for integrating renewable energy sources into everyday infrastructure with a walkable photovoltaic floor that reach a nominal power of 173 watt peak per square meter. The PV crystalline glass features complete opacity, incorporating a 100% coverage ceramic frit. This innovation proves to be highly efficient, generating over 40,000 kilowatt-hours per year. Fjord House is the first building designed entirely by artist Olafur Eliasson and architect Sebastian Bayman. Rising directly from the harbor of Vejle, the building brings together years of research in diverse fields into one project: urban space, light conditions, nature, physical movement, and the most innovative sources of renewable energy. The nominal power of this project reaches 173 watts peak per square meter, and the external light reflection stands at 8%. To learn more about this project, you can scan the QR code available in our catalog or visit our website for detailed technical data and videos. Apple Store exemplifies a blend of cutting-edge technology and environmental consciousness, a hallmark of Apple's brand philosophy. A particularly noteworthy feature of this store is its innovative photovoltaic walkable floor installed on the rooftop, a clear indicator of Apple's commitment to innovation, sustainability, and renewable energy. Thanks to the design of Foster Plus partners, Apple has been able to implement this walkable roof that also generates electricity, padding the way to a clean and sustainable future. Onyx Solar supplied approximately 6,000 square feet of crystalline silicon PV glass, featuring a textured anti-slip finish and a black color ceramic frit for maximum opacity. Each PV glass panel is about 10 feet by 5 feet, and it was installed by renowned Seal. As we continue to push the boundaries of sustainable design, the importance of assessing environmental performance and creating future-proof solutions becomes paramount. As Norman Foster aptly puts it, led by our environmental engineering team, we assess the environmental performance of our projects and develop innovative, future-proof solutions to mitigate the impact of climate change. The City of Arts and Sciences in Valencia, Spain. The City of Arts and Sciences of Valencia has installed more than 6,000 square meters of photovoltaic walkable pavement on the cantilevers of the Science Museum. This floor, made up of crystalline silicon cells that is patented by Onyx Solar, generates a good part of the electricity demanded by the building's facilities. The execution of the project to install photovoltaic solar pavement on the museum's cantilevers contemplate its placement on the two exterior cantilevers with a maximum installed power of 553 kilowatt peak power, which means generating up to 30% if the energy demanded by the building in some seasons of the year. This museum is a cultural and architectural complex located in Valencia, Spain, that has become the most important and modern tourist destination in this city and one of the main treasures of Spain. It was designed by Santiago Calatrava and Felix Candela. Now, let's go over the technical details. It reaches a nominal power of 129 watts peak per square meter. The visible light transmittance is 28%, and the external light reflection is 8%. Timber Cove in California, United States. Onyx Solar provided crystalline silicon photovoltaic glass for a high-end residential resort in Sonoma County, located in Timber Cove, a picturesque cliffside area overlooking the Pacific Cove, a picturesque cliffside area overlooking the Pacific Ocean. This project involves 3 roofs for 3 buildings: the main hall, guest rooms, and the garage. The installation includes trapezoidal crystalline silicon pieces in 3 shapes, an anti-slip finish, and a ceramic black frit on the back. Collaborating with Eckersley O'Callaghan, this project marks a significant step in constructing such complexes, proving that luxury service standards can coexist with sustainability and self-consumption. Chapter 13. Projects, Balcony, Parapets, and Railings. Hidden crystalline silicon, CO2 neutral residential in Urdorf, Switzerland. The innovative energy harvesting technology installed in this project reduces home running costs to almost zero. In this development, the photovoltaic material is discreetly integrated into the facade of the building and the balcony parapets. The PV building materials supplied for the balconies have a white satin finish on the front and black ceramic frit on the reverse for optimal aesthetics and integration. Onyx Solar's innovative building materials supply energy to homes throughout the year, which drastically reduces the cost of running the apartments. The surplus energy in summer is injected into the supply network. This residential complex in Urdorf, Switzerland, is demonstrating how pioneering technology can allow tenants to live comfortably with little or no electricity or heating costs. It has the potential to be replicated because it contributes to the achievement of the federal energy strategy and also illustrates a method to counteract winter energy shortages. Its nominal power reaches 124 watts peak per square meter. The U value, which typically measures thermal insulation, is 0.96 watts per square meter Kelvin, or 0.96 in British thermal units per hour per square foot per degree Fahrenheit. Lastly, the external light reflection is 8%. The building stands as a remarkable example of sustainable architecture designed to offer its tenants not only a comfortable living environment, but also significant energy savings. The innovative use of photovoltaic systems on the roof, facade, and balcony parapets ensures that the building operates with complete CO2 neutrality. As architect René Schmid describes, this building is completely CO2 neutral. Tenants pay no energy costs for household electricity, heating, and cooling, and they live in plenty of comfort. This is ensured by the photovoltaic system on the roof, the facade, and the balcony parapets. To learn more about this project, you can scan the QR code available in our catalog or visit our website for detailed technical data and videos. Amorphous Silicon Technology. The General in Melbourne, Australia. This project, located in Melbourne, The General, an 8-story mixed-use development, stands out as a pioneering sustainable building. It is the first in Australia to integrate solar photovoltaic glass on a facade and railing, achieving a high-quality 7.5-star energy rating and offering a sustainable alternative to typical apartment buildings. In the General project, Onyx Solar provided amorphous silicon photovoltaic glass, selected for its low light transmittance, is a testament to the architect's vision of creating a building that is both functionally and visually harmonious with its urban surroundings. Now, Let's go over the technical specifications. It reaches a nominal power of 40 watts peak per square meter. The visible light transmittance is 10%, meaning only a small amount of light passes through. The solar factor is 17%, and the U value, measuring thermal insulation, is 0.98 watts per square meter Kelvin, or 0.98 in British thermal units per hour per square foot per degree Fahrenheit. Lastly, the external light reflection is 8%. ECO building. One of the key attributes of the PV glass manufactured for this project in Shanghai is its see-through possibilities. This allows for natural light to permeate the building, creating a bright and welcoming environment. At the same time, it provides the necessary shading to maintain a comfortable environment. We worked closely with our clients to tailor the level of transparency and power output to their specific needs and preferences. For this project in Shanghai, we manufactured PV glass with a high degree of transparency, striking the perfect balance between visibility and energy generation. Its nominal power reaches 28 watts peak per square meter. They have a visible light transmittance of 30%, and the solar factor is 38%. The U value, which measures thermal insulation, is 0.98 watts per square meter Kelvin, or 0.98 in British thermal units per hour per square foot per degree Fahrenheit. And the external light reflection is 8%. Chapter 14. Certifications. At Onyx Solar, we are committed to delivering only the highest quality products, which meet stringent international standards, codes, and safety guidelines. Every step of our production process, as well as the materials we use, have been thoroughly verified by independent certifying associations. Our dedication to quality is demonstrated through our various certifications. Over 50 of our products have obtained their corresponding UL certifications, making Onyx Solar the leader in photovoltaic glass certification in the United States. Our crystalline and amorphous silicon glass panels are certified by UL according to the strict safety standards. In addition to this, our photovoltaic products also comply with IEC standards. These certifications cover terrestrial photovoltaic modules, including design qualification, type approval, and safety qualifications. We also take fire safety very seriously. Our photovoltaic glass is classified as a Class A material. Furthermore, our commitment to quality extends beyond these certifications. Onyx Solar's products are also certified under ISO 9001 and ISO 14000, which cover comprehensive quality control protocols from raw material traceability to in-house inspection and post-production control. This ensures that each PV glass unit leaving our factory meets our exacting quality standards. For our clients in the UK and other regions, we also hold MCS certifications and several other local certifications. You can stay updated on all our certifications by scanning the QR code provided. We invite you to scan the QR code to access detailed information about our certifications and to ensure that our products meet the specific standards required for your project. Chapter 15. Global EPD. At Onyx Solar, we prioritize transparency and environmental responsibility. That's why we have obtained the Global Environmental Product Declaration, or EPD, for our crystalline photovoltaic solar glass. This EPD is a certified document that offers our clients reliable, verified, and transparent information regarding the environmental impact of our products throughout their entire life cycle. This information comes from a detailed life cycle analysis, or LCA, which follows strict rules set by the Eco-Labeling Program. For our products, this study is done according to the standards of the Product Category Rule for construction products. We're also proud to work with Eco Platform and AENOR. These organizations ensure the quality and accuracy of environmental declarations across Europe. Eco Platform creates a common standard for these declarations, and AENOR helps verify that our products meet the highest European standards. These certifications show our dedication to reducing environmental impact while maintaining top-quality products. For more details, you can scan the QR code to download our EPD and learn more about our environmental efforts. Chapter 16. Courses, webinars, and resources. At Onyx Solar, We offer a range of resources and educational opportunities to support architects, engineers, and construction professionals in integrating photovoltaic glass into their projects. You can access our webinars, available in several languages, by scanning the QR code found in our website and physical catalog. These webinars provide comprehensive details about our technology, along with all the necessary documentation for specifying, prescribing, and installing photovoltaic glass. We also provide a dedicated section on our website called Resources. This area includes a variety of online tools, technical information, and additional resources to help you understand and specify PV glass for your projects. The QR codes to access this section can also be found in our website and physical catalog. Our resources include Technical Guide. This document contains data sheets for some of our PV glass products, along with other valuable information. If you have any special requirements for customizing your PV glass, please reach out to us. Product Manual. This manual covers everything you need to know about electrical and mechanical installation, handling and packaging, preventive maintenance, certifications, cleaning, and warranties. Installation Guide. A glossary of terms to help you fully understand specific words related to the integration of photovoltaic glass into buildings. Glass Specifications. Examples of specifications in the formats of both the Construction Specifications Institute and the National Building Specification. For architects and designers, we also offer AIA-certified courses through the American Institute of Architects. These courses are designed to help you stay current with architectural practices and advance professionally. For more information, please contact us at USA@onyxsolar.com. Factory. As Onyx Solar, we are proud to be the world leader in the design and manufacture of architectural photovoltaic glass for buildings. Our journey from the early stages of research and prototyping to the final stages of product design, manufacturing, and customer validation has been a testament to our commitment to innovation and excellence. Today, our cutting-edge products are installed in over 500 projects worldwide. We have successfully brought together two independent industries in a way that has never been done before. Under our roof, the traditional photovoltaic industry and the construction sector merge to create a superior, multifunctional architectural glass with photovoltaic properties. Our Onyx Solar PV glass has been rigorously tested to UL and IEC standards, which are among the most important test programs to complete in both the USA and Europe for commercializing our products. Our state-of-the-art facilities are located in Avila, Spain, just an hour away from Madrid. These facilities are not just production sites. They also include a large showroom with full-size mock-ups, providing a comprehensive view of our products. We encourage visits to our facilities to learn more about what we offer. We are also proud to hold the ISO 9001 and ISO 14001 certifications, which ensure the quality of our products and processes, further affirming our commitment to excellence and environmental responsibility. Chapter 18. Research and Development. Since our inception, we have remained steadfast in our commitment to continuous investment in research and development, a crucial element for success in this rapidly evolving technological landscape. These programs often include collaborations with research centers, universities, and third-party companies. Our R&D department is bolstered by a dedicated team of physicists, architects, and engineers who work in close coordination. There's a strong, direct, and ongoing communication channel between this department and our sales and marketing team. This synergy fosters an evolving R&D corporate strategy that merges the critical thinking of our technical team with the market insights from our sales and marketing department. Our collective aim is to lead the industry, designing new products that can be integrated efficiently and economically into the building envelope of any building worldwide. To discover some of the exciting projects we are currently involved in, we invite you to scan the QR code above. Chapter 19. Awards. Since our inception, Onyx Solar has received over 100 international distinguished awards, establishing us as the most award-winning photovoltaic company worldwide. Among these, we are particularly proud of the recognition from the U.S. glass industry as the most innovative glass of the year. Additionally, buildings outfitted with our technology have earned numerous awards, frequently achieving LEED certification. These honors are a testament to our unwavering commitment to innovation and sustainability in the photovoltaic industry. Nevertheless, the greatest affirmation of our work is the trust placed in us by our clients. This is what we strive to earn every day through our steadfast dedication to delivering the highest quality and excellence in all our endeavors. Chapter 20. Shareholders and Clients' Testimonials. Onyx Solar is supported by a robust shareholder base, providing the company with the stability it needs to undertake large-scale projects. The company was founded by Álvaro Beltrán and Teodosio del Canto, and a key supporter is the JME Fund, led by José Manuel Entre Canales, who is also a major shareholder in Acciona. Among the other significant shareholders are notable businessmen like Christian Gut, the largest shareholder in Prosegur, as well as influential figures in the financial sector such as Jaime Castellanos, chairman of Lazard, and Claudio Aguirre, chairman of Altamar Capital Partners. Regarding our client testimonials, we have completed over 500 projects in more than 60 countries, several of which are large-scale developments for renowned companies such as Apple, Samsung, Microsoft, Hewlett-Packard, Pepsi, Coca-Cola, McDonald's, Heineken, Balenciaga, Marriott, Pfizer, and Novartis. We also collaborate with architects, engineers, consultants, and contractors worldwide, including Foster plus Partners, Perkins plus Will, SOM, Pelly Clark, Vignoli, AECOM, or Eckersley O'Callaghan. We have also worked with some of the most important global titans in the construction and real estate industry, such as ACS, Skanska, Acciona, Turner Construction, Ferrovial, or Jacobs. Please take a look to our customers' testimonials and much more scanning the QR that you have available in our website and catalog. Thank you for joining us on this journey. As we close, we encourage you to keep exploring the vast possibilities that photovoltaic glass offers. Whether you're planning your next project or simply seeking more information, our team is here to support you every step of the way. We invite you to continue exploring, whether through our website, our catalog, or by reaching out to our team. We look forward to collaborating with you to create spaces that not only inspire, but also lead the way in sustainability. Your next project could be the one that redefines what's possible, and we're excited to be a part of that vision. Thank you for listening.